Hi, everybody. Mr. Lake here with another chemistry video. Today, we're talking about binary ionic compounds, which are the simplest form of ionic compounds. And we're going to go through how to write formulas and how to write names for these simple ionic compounds. Let's get started. So, we already talked in the last video about how positive ions, cations, and anions, which are negative ions, like to get stuck together, right? They form those ions because those atoms exchange electrons and then they have a charge which makes them attracted to one another and they get stuck together. And that sticking together is called an ionic bond. Now, this often happens with metals and nonmetals because metals like to form cations, nonmetals like to form anions. And so it is very often that you find ionic bonds between a metal and a nonmetal, or sometimes multiple metals and multiple nonmetals. When you just have one, when you just have two elements present, one metal, one nonmetal, this is called a binary ionic compound because binary means two. And so it's an ionic compound composed of just two members. We're going to jump right in to writing formulas for these binary ionic compounds. And something that we need to introduce here is the idea of subscripts. So, subscripts are those little numbers that are written kind of on a line beneath the normal line of writing. So, you've seen these before. We've already used subscripts in other contexts, but you'll have your regular size writing, and then there'll be like kind of a small below a line of writing that's small and below the rest, and those are the subscripts. I think this will make more sense if I just show you. So let me show you. First of all, I'm just going to give you an example, and then I'm going to explain to you how you would do something like this. Calcium and oxygen form the binary ionic compound called calcium oxide. And the formula for calcium oxide is CaO. You might notice that that is the element symbol for calcium, and that's the element symbol for oxygen, which makes sense. Written together, they make the formula for the compound. Now, there's no subscript in this um, name. There doesn't have to be, but if I wanted to, I could write ones beneath that. So the questions I'm about to answer, I'm going to explain how to do these formulas, and what I'm going to answer, if you are asking these questions, is how do you know what the subscripts are? How do you know what the formula, or sorry, the symbols are? How do you know what order to write things in? And how do you know what to call it? We're going to focus on this first. So, when you are trying to come up with a formula for a binary ionic compound, first of all, what you have to do is you have to determine the charge of the cation and the anion. So, in that example that we just did, it was calcium and oxygen. In the last video, we talked about how you can use the periodic table to determine what the charge of something is just based on where it is, what column it is in the periodic table. Calcium is in the second column. It has two valence electrons. So calcium is an element that likes to form a 2 plus cation. Oxygen is way over in the third to last column. It has 6 valence electrons. And so it's always going to try to gain 2 valence electrons, which means that oxygen likes to form a 2 minus ion. So that's step one, is just look at each of the elements individually, find them on the periodic table, determine what charge they like to form as ions, and write it down somewhere so that you have it. Now, what we need to do is find the lowest number of each that combines to form a neutral charge. This is like the key. This is really this is the step in finding the um, formula. Because step one is just kind of like setting the stage. Step three is just kind of wrapping things up. Step two is 80% of the whole process. So here's what this means: we could have one of each of these, or we could have any number of each of these ions. So we could have three calciums and one oxygen, or two calciums and two oxygens, or one calcium and four oxygens. We have any number of the two ions could come together in order to form an ionic compound. But what determines how many of each will combine is that it's always going to end up with a neutral charge, meaning the charge is zero. So the positive charges and the negative charges have to cancel each other out. There can't be anything left over. This happens to be a really easy example, this calcium and oxygen example, because calcium forms a 2 plus charge. Oxygen forms a 2 minus charge. So if you take one of each of those things, then you have a 2 plus and a 2 minus. Those are going to cancel out and equal 0. So in this case, it's a 1-to-1 ratio. It's only going to take one calcium and one oxygen. So now we're ready to move. Now that we know that, we're ready to move on to step 3, which is just write the formula. And the way to write the formula is that you always write the cation first. So it's going to be calcium, because in this case, that's the cation. Write that first. And then the anion second. So oxygen comes second. Now we have to make sure that our subscript indicate the number of each element involved. Well, we just decided that it's going to be 1 and 1. So we could write 1 and 1 there. However, chemists are super lazy, and chemists don't like to write ones. So in compound formulas, anytime the subscript is 1, you just don't write anything. And that indicates that there's only one thing there. Let's do some examples. I'm going to do one more example, and then I'm going to let you do the other 3 on your own here. I'm not going to do the first example. Actually, I want to do aluminum and bromine. So step 1, find each of those elements on the periodic table and figure out what their ionic charge is going to be. So aluminum is Al. And if we find aluminum, it's in the column with 3 valence electrons. So aluminum likes to form a 3 plus ion. Bromine is one of the halogens, and it likes to form a 1 minus ion. So now, how many of the 2 of these things will need to come together in order to form a neutral charge? Well, it's not going to be one of each, because we have something that forms a 3 plus charge and something that forms a minus 1 charge. And so if you brought one of each together, you'd still have 2 plus charges left over. And this one's pretty easy because you can probably see, well, okay, we just need one of these and then 3 of these. 1 aluminum, 3 bromines, and then that will be 3 plus and 3 minus. And that will cancel out and equal 0. So the way we would write that is AlBr3. Cation first, anion second, and then subscripts to indicate how many would need to come together to form a neutral charge. 1 aluminum and 3 bromines would give us 3 pluses and 3 minuses, and that equals 0. And that is good. Please, at this point, pause this video and take a few minutes to attempt the other 3 examples on this slide. I'll stop talking for a couple of seconds. So pause the video, and then I'll show you how these are done. I hope you paused the video and gave these a shot. Let me show you the answers. First of all, sodium and chlorine. Sodium is one of those elements where the symbol doesn't match the name. So the symbol for sodium is Na, not like S or SO like you might think it is. It's because there's a lot of other elements that start with S. So sodium is Na, and sodium is in the first column, meaning that it likes to form a plus charge. Chlorine is one of the noble gases. It likes to form a -1 charge. Well, this is easy. 1 plus, 1 minus. We just need one of each. Beautiful. NaCl is going to be the answer for the first one. Strontium and nitrogen. Okay, strontium is in the second column. Its abbreviation is SR, and since it's in the second column with 2 valence electrons, it likes to form a 2 plus charge. Nitrogen is over here. It has 5 valence electrons, so it likes to form a 3 minus charge. Okay, now this is tricky because it's not one of each, right? A 2 plus and a 3 minus aren't going to come together and cancel out and form 0, but it's also not just one of them and a multiple of the other. We're going to need multiple of both of them in order to form a negative charge. So I'm going to show you 2 different techniques for figuring this out. The first technique is just add what you have the least of. That's a name in progress. I need to come up with a catchier name for this process, but it's basically you add another one of whatever you have the least of. So in this case, if we had 1 strontium and 1 nitrogen atom, we'd have more negative charge, right? We'd have 2 plus and 3 minus. So let's add another strontium into this equation. If we had 2 strontiums and 1 nitrogen, now we have 4 plus total and 3 minus. So now we're short on the negative charges. So let's add another nitrogen into the mix. Well, with another nitrogen, now we'd have strontium 4, or 4 plus, sorry, and 6 minus. So now we're short on positive. So let's add another strontium to add some more positive. Now we have 6 plus and 6 negative. So by just kind of like adding another atom of whatever charge we have the least of, we eventually got to a place where they evened out. And so it's going to be 3 strontiums and 2 nitrogens to get here. 3 strontiums, each with a 2 plus charge, gives us a total of 6 plus. 2 nitrogens, each with a negative 3 charge, gives us a total of 6 minus. That equals 0. That's what we want. I told you I was going to show you a second way. The second way is one of my favorite things that we do in chemistry. The second method for determining this is called the cross drop. And I'm going to show you a dance move that illustrates what you do in the cross drop. Let me show you that again. What you do in the cross drop method is you take the charge. Let me erase some of this so that we can really appreciate what's going on. In the cross drop method, the charge of the cation becomes the subscript of the anion, and the charge of the anion becomes the subscript of the cation. So in our formula, we're going to have those 2 symbols, right? So we're going to cross drop this number down here and this number down here. The 2 goes here, the 3 goes here. Check that out. That's the same formula. So you don't have to do the whole guess and check thing if you don't want. This works for any combination. And in fact, you'll notice that it worked for the others too, right? There's a 1 plus charge, 1 minus charge up here. Cross drop those, and you get 1 and 1. There's a 3 plus charge here and a negative 1 here. Cross drop those, and you get 1 aluminum, 3 bromines. It always works. The only situation where it doesn't work would be something like calcium and oxygen, where you have 2 plus and 2 minus. If you cross drop those, you would get calcium 2 and oxygen 2, but that's not the lowest common denominator. We actually only need one of each of these. So you do have to be a little bit careful with the cross drop method, but it always gets you the right ratio. You might just have to look and say, is there a way that I can make those subscripts a little bit smaller in order to, after doing the cross drop method? So again, you can just add whatever you have the least of, or you can do the cross-drop method in order to figure out what the ionic compound formula is going to be. Now, lithium and sulfur, let's do this example. Lithium is in the first column, so it's going to form a plus charge. Sulfur is in the column with 6 valence electrons, so it likes to form a 2 minus charge. Let's cross drop. The 1 goes below the sulfur, and the 2 goes below the lithium. So it's going to take 2 lithiums and 1 sulfur. Notice that this is very important, notice that when you cross drop, you don't take the charges with you. So the subscript should never have a plus or minus in it. The subscript is just a number of how many atoms are in the formula. So, and this is a very common mistake when people start using the cross drop method, is that they'll put 3 minus and 2 plus down here, for example. That's not how you should do it. So when you cross drop, also remember, drop the charges. Cross drop, drop the charges. Cross drop, drop the charges. I will stop. Now you also need to know what to call these things, how to write and how to say their names. Well, for binary ionic compounds, it's really simple. There's always going to be 2 words in the name of a binary ionic compound. In fact, most compounds, there's 2 words. The first word is just straight up the name of the cation, the element name of the cation. The second word, you're going to take the name of the anion and you're going to change the suffix to "ide." So you're going to take the root of that element name and then add "ide" at the end. So our original example was calcium and oxygen. Whoops. And they formed this compound here. Well, to name that compound, you just take the name of the first element right off the periodic table, calcium. And then for the second word, you take the root of the second element and change the ending to "ide." So calcium oxide. This will take a little bit of getting used to. You're going to have to just see examples of a lot of the different elements used in this way, and you will get used to how to change their names. So let's do some examples, some practice. I'll do the first one as an example. Mg and O. Well, that's magnesium and oxygen. So the name is going to be magnesium. And then oxide. I'm going to disappear. Take a few seconds, pause the video, and do the other 3 examples. I hope you paused the video. I'm back. Let me show you how to do these other 3. The second binary ionic compound that we're looking at here is potassium and chlorine. So the name is going to be just the name of the cation, potassium, and then the name of the second atom, or the anion, sorry, the name of the anion with the ending changed to "ide." So chlorine changes to chloride, potassium chloride. Maybe these names are sounding like some of the things that you've seen or heard before. H2S, so this is hydrogen and sulfur. Hydrogen sulfide. This is also interesting because this is an acid as well, and we will get into, hopefully we'll spend a little bit of time talking about acids and how they are special compounds and their naming works a little bit differently. But a correct name for this compound is hydrogen sulfide. It just, some things have multiple names. This last one is strontium and fluorine. So it's going to be strontium fluoride. Notice that you don't have any subscripts or any numbers in the name. And that's because the numbers in the compound are completely driven by the charges of these elements or the ionic charge that they tend to form. And so you don't need to indicate that in the name for a binary ionic compound because you can always figure that out using the periodic table. For some other ionic compounds, and for when we get into covalent compounds, it is important to have recognition of numbers of things in the names. But for right now, this is why we start with this simple example. This is what we're going to go with. It doesn't need to be more complicated than this yet. So that's it. In our next video, we're going to add in polyatomic ions and what to do with those. And then in future videos, we'll talk about what to do when one of the ions is a transition metal. That adds a whole extra element, but that is fun for the future. So that's it for this video. Thanks for watching. And until next time, take care of yourselves.